Okay, so this third segment is really just an introduction, brief introduction to the periodic table. And you can read greater details in the textbook, but I think I can get you through most of what you'll need to know at this point. Chapter 7 will talk about all of the characteristics and traits of the occurrences in the periodic table. So, what is the periodic table? It's a systematic catalog of elements. The elements are arranged according to atomic number. And so, at least in this periodic table, the atomic number is on the top, the atomic weight is on the bottom, and as always, the atomic symbol is right in the middle. So, we talk about the periodicity of the periodic table, and we'll actually do a whole chapter on periodicity, and that's all about the trends and occurrences within the periodic table. And so, what is periodicity? It's a repeating pattern of chemical and physical properties. And so, what does that mean exactly? Well, the law of chemical periodicity is that the properties of elements are periodic functions of their atomic number. And so what that means in more applicable terms is that elements in the same group have similar chemical and physical properties. So if we go back a page to, sorry, it's not going back for me. If we go up, sorry. So here in this small little periodic table, so just a couple of names to know associated with the periodic table. So you want to know that everything that goes vertically up from top to bottom is called a group. And the groups are numbered in a couple different ways. It goes sequentially left to right from 1 to 18. And then there's another method of organizing or naming them. We use the A's and B's, so it's 1A, 2A, 3B, 4B, and so on. So I always say the tall columns are the A's if you're using the AB notation. Sometimes it's just much easier to refer to it as group 1 through group 18. And so the horizontal rows are called periods. So we talk about it as period 1, period 2. Starting here, I always say these numbers identify the periods for you. And so we have many different areas of the periodic table that we'll talk about what these names are eventually. Of course, you don't have to have them memorized, but it's nice to just know, be familiar with them. So group 1A, that's my first group, my first vertical column, called alkali metals. Second, 2A, top to bottom, alkaline earth metals. And then 6A, which would be over here, are called the chalcogens. And then the 7A are called, that's not very common that they're called the chalcogens. Typically call it the carbon family. Sometimes groups are also referred to as families. These are the halogens, all right, the 7A, and then the 8A are the noble gases. And then when we look at the periodic table, we want to be able to identify what side of the table has the metals, what side has the non-metals. So we always identify this staircase on the periodic table. And so everything to the left of the staircase is considered a metal. Everything to the right is considered a non-metal. And those elements that border the staircase, those that are in purple here, are called the metalloids. I know there's a tiny little periodic table. This one's a little bit better. So here are your metalloids. There are 6 of them: boron, silicon, germanium, astatine, antimony, and tellurium. Those are going to be your 6 metalloids. And metalloids are elements that have characteristics of both metals and nonmetals. They're considered semiconductors, metalloids, or semi-metals. So we also want to be able to look at what chemical formula is. And so a chemical formula has subscript to the right of the symbol of an element. It tells the number of atoms in that element in one molecule of the compound. So I like to use something that's very familiar to you. So this we call the subscript in the chemical formula. And later on, we'll talk about coefficients when we are balancing equations. And the other thing that we want to look at are, hang on, sorry, some diatomic molecules. What are diatomic molecules? Diatomic molecules are elements that exist naturally in the diatomic state. So there are always 2 of them. And in a few chapters from now, we'll talk about why that's always true. But as we get into writing chemical equations, it's going to be very important that you know these 7 elements that exist diatomically. So what I'd like to do is take you to this website that you might want to bookmark for yourself, which is ptable.com. And this p-table is a really good example of some of the properties that we'll talk about, or it illustrates, not an example, it illustrates the properties of the elements that we'll talk about when we do chapter 7 on periodicity. So just to refresh, because this is a little bit bigger, nicer, we have our alkali metals, we have our alkaline earth metals, we have our halogens, we have our noble gases. And I'm sorry, I made a mistake before. I called this the carbon family. It was not. It was that chalcogens. This is this area in here that's all pink. These are called the transition metals. And these down here, these 2 long rows are called the rare earth elements. The lanthanide series and the actinide series. And then you have your boron, silicon, germanium, astatine, antimony, and tellurium. Those little teal blue ones those are your metalloids again. Sorry, I had a mental blank. So when you look at the periodic table, you see that there's this missing link in here. So elements 57 through 71 are down here. And the reason for that, they actually belong right here, but they have their own separate characteristics, and that's why they have their own name, lanthanide series and actinide. But you could slip them in here and it would just make your periodic table much too long and not practical for textbook purposes. So this is really nice because, as you can see, as I'm scrolling over things, it highlights different elements and it gives you, the important features of what is illustrated in this symbol. But as we go along and we start talking about the periodic trends, I'll highlight some of the important aspects about atomic size and about electronegativity values and electron affinity values. And there's a lot of different aspects to this that are very, very helpful. So you would want to go over here to click on this to talk about, to look at what are the radius values. And then this periodic table will switch over to give you all of those characteristics and traits. So for instance, density. So if I click on barium, I could get the density of barium in kilograms per meter cubed, and so on. So this is just a really nice periodic table, very illustrative to kind of highlight the major things that we're going to want to use. So what are the diatomic elements? You need to know what they are. I always tell people to look at on this table. The diatomic elements start here at nitrogen and go over. You can form a 7 from nitrogen down to iodine. And that 7 that you form will point out the diatomic element. And the way to remember it is that there are 7 of them. This forms a 7 starting at nitrogen going down to iodine, but there's only 6 there. 1, 2, 3, 4, 5, 6. Hydrogen is the outlier here. It's just a handy way to remember which ones are diatomic. And when we call them diatomic, what we're saying is that if I were to write the symbol for hydrogen, kind of just like oxygen is written here, if I were to write the symbol for hydrogen, I would have to write it just hydrogen gas. It's always written as H2, nitrogen is always N2, oxygen O2, fluorine is always written as F2, chlorine, Cl2, bromine, Br2, and iodine, I2. So those are your 7 diatomic molecules. That's something you just want to know and have in your back pocket when you're writing chemical equations, trying to name certain components of a reaction. It will help. Okay, I'm going to stop there.